and then share my screen again. Do you think something's actually happening with my friends this morning, or do you think that they're just talking about nothing? I'm gonna guess nothing, but it always makes me nervous when I hear like 85 messages in a row. Doesn't seem like anything important's happening. Turn off. No. There we go. Okay. So a binomial experiment has the following conditions. The first condition is that you have a fixed number of trials. Meaning you're like, I'm going to do this experiment 5 times. A second thing is that there are only 2 possible outcomes. Success and failure. That's where the bi comes from in binomial, right? Like bicycle or bisexual 2. The probability of success is the same for each trial. Hey, people online, I'm using an orange pen. Can you still read it okay? Okay. Number 4 is that X means how many successes you have. Or I guess you want. I'll tell you, anytime I have a word where it's like multiple, like 2 C's and 2 S's in it, I'm like, I'm wrong. I must be wrong. I am definitely not spelling this right.
Necessary? That is an impossible word. I
Yep.
have no idea.
I know. Or, well, disappointment. I'm always like, is it 2 S's? Is it 2 P's? And I never know until I like write out, and then I'm like, this is it. No, that one's wrong.
Tomorrow, I always thought there was 2 M's and 2 R's. There's only 1 M. It's like, who came up with it?
I'm glad that we found this moment together to talk about this. This is important. All right. So you're gonna see a lot of this NPQX a lot throughout this course. And you kind of already know this is the number of trials. X is how many successes we want. P is the probability of success. And Q is the probability of failure. Okay, well, apparently I didn't finish writing this. This should say successful surgeries. Okay, a certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. Okay, so we've got to just decide, is it binomial or not? Okay, so I'm just going to go down the list. 1, 2, 3, 4, and by 1, 2, 3, 4, I mean the top of the page where we said this is what's required to be binomial. So first thing, is there a fixed number of trials? How many trials are they going to do? 8. There's 8 trials. We're good there. They've already decided it's going to be 8 patients. Possibility, 2 possible outcomes, success or failure. True, like a surgical procedure is either successful or fail. That's right. Probability of success is the same for each trial. It says that it's 85% for every single trial. So that's right, 85%, yes. And then X is how many successes you want. So it says the random variable represents the number of successful surgeries. Yes, so this is binomial. Okay. So let's try B together as well. A jar contains 5 red marbles, 9 blue marbles, 6 green marbles. You randomly select 3 marbles from the jar without replacement. The random variable represents the number of red marbles. All right. Okay. So 1, 2, 3, 4. Remember, if we get a no on any of these, it's out, right? All right. So first one. Are there a fixed number of trials? Does it say how many times we're going to pull a marble out of the jar?
It just says 3 marbles.
Yeah, it says we're going to do 3 in a row, right? So 3. All right. 2 possible outcomes, success or failure. I guess it represents how many red marbles we get. So we could call a success or a failure. Did you get a red? Yes or no? Success or failure. Number 3, does the probability of success stay the same for every trial? Okay, so what's the probability of you drawing a red marble the first time? There's 5 red, 9 blue, and 6 green. 5 out of all of those added together, right? Which, we probably could add together, but why would we? Let's not do it. So 5 out of however many, right? Okay. But it says that it's without replacement. So the second time you pull a marble, will the probability of getting a red one be different?
Yeah.
Yeah, because you'll have 1 less in the total and possibly 1 less red marble. So it's a no here, so we can just stop. It's not binomial.
So anytime it says without replacement is a no?
Yes. All right. Why don't you guys try example 2 and I'll give prizes for it. So there's example 2. You can read it. Is this a binomial experiment? Do you still have that question for me or did David answer it, Emily? Okay. And I just need to know at the end of the hour if you guys feel like you want one more day before you take that test or if you want to take it tomorrow. Okay, who's up for it? Hands up. Krista's 1. Am I going too fast today? A little bit more time.
Yeah.
Caitlin is number 2. Three for Megan. Michaela, Tanner, no? Mitchell, you up for it or no? Okay, you all right? You having a bad day? Okay. 2. Caitlin.
I said that it is binomial
Binomial, yes, it is.
because for the first one, there's 10 trials.
Mm-hmm.
For the second one, there's only like 1 chance you can be right or else you can't be.
Right, so it's success or failure on the quiz, yeah, I mean on each problem.
And then the third one, there's like a 25% chance that you can be right.
Right? Every time?
Yeah. And then for the fourth one, we know how many successes we want.
Right, it tells you how many, it was the correct number of correct answers. So yep, that's binomial. You can usually tell a binomial question because it's a whole bunch of trials. They tell you how many it is, and then it's always like a yes or no, or a true or false, that kind of thing. Caitlin, bouncy ball or hippo or lion?
Hippo.
Okay. I think so too.
I have a hippo of my own.
She does. She's got a hippo of her own. Do you have them all laid out at home? So just Krista now, right? All right, so here's the formula for a binomial experiment. It is n choose x times p to the x times q to the n minus x. It is actually surprisingly easy to understand, but it looks horrible, doesn't it? So what we're going to do is I am going to actually show you 3 different ways to do a binomial. And one way is by using the formula. And down here, we're going to do the formula for 3, 0, 1, 2, 3, these two. And we're going to use our calculator for those two. And we're going to use the table for the ones on the bottom. So this is what mine looks like. So basically, I'm going to show you, we're going to do a probability distribution down here with binomial, and 2 of them we're going to do using the formula. 2, we're going to use our calculator, and 2, we're going to use the table in the back of the book. They're all pretty easy, but I want you to kind of decide what you're most comfortable with. So I'm going to show you all of them. Down here, we're going to write down that the x, this is probability of x. This is 0, 1, 2, 3, 4, 5. Okay, now this problem says that a card is selected from a standard deck and replaced. That's important. It was replaced, right? Like Megan said, if it wasn't replaced, it wouldn't be binomial. It's done a total of 5 times, so we know how many times it is. A success is selecting a club. Okay, so let's use the formula for this first one. How many trials are we doing? Maybe we should write out this stuff on the side here. N equals P equals Q equals. And there are 5 trials. What's the probability of success for getting a club if you just pick a card?
Like 4 out of 52, or a club is like 13 out of 52.
Right, which is actually 1/4, because a quarter of the cards are clubs. And failure then would be 3/4. Okay, so here's the formula. It is 5, choose x, in this case is 0 because that's what we're on right now, is 0, times success, which is 1/4 to the 0 power, times failure, which is 3/4 to the 5 minus 0, which is 5. And I want to explain why this works. So you don't have to write down, you can write down what I'm about to write down, or you don't have to, it's up to you. I think this is actually pretty easy to understand compared to a lot of other formulas in this book. Okay, so let's say that you're picking 5 in a row and you want them all to be failures. That would be 3/4, 3/4, 3/4, 3/4, right? Because we're saying we want 0 successes for this one. Everybody understand what I'm doing? Okay, Mitchell, are you with me?
Yeah, I was writing that down.
Okay. So this is 5 failures in a row. Do you see how that's 3/4 to the 5th power right there? That's where that comes from. That's how many failures I want. And then how many successes do I want? None this time, right? Because I said that I want x is 0, 0 successes. So that's 1/4 to the 0 power. What's anything to the 0 power? Anybody remember?
To itself, isn't it?
Nope. That's to the 1st power, and it's not 0. Anybody remember to the 0 power? 1. So anything to the 0 power is 1. So that will just basically cancel this out. And this tells you how many different ways there are to do it. So let's just put this in our calculator first, and then we're going to try a different one, and I'll explain the formula again. I think you'll get it. So Matt, hit 5 first, and then go on to probability to that NCR. you can put in, if you want to, 1/4 in parentheses to the 0 power, but that's just 1, so you don't even have to put it in. And then 3/4 to the 5th power. Make sure it's in parentheses. Did you guys get 0.2373? Caret 5. Do you remember what all these are going to add up to? 1. Okay, so you guys tell me, if you had a deck of cards in front of you, the chances that you would pick 0 clubs is about 24%. Does that feel right?
Yeah.
Yeah, that seems right to me too. What's a weird answer for here? Yeah, there'd be no chance of you ever selecting a club. Well, that can't be correct, right? Because you could easily do it.
Like 80%.
80%, that's probably too high, right? That feels too high. So make sure you're reading the problem, you're understanding like what we're looking at. All right, now we're going to jump down to number 3. So this one's going to be 5, choose 3 this time, times 1/4. How many successes do we want this time? 3. And how many failures do we want? 2, because there's 5 total trials. So I'm going to draw this down here again. So just wait on doing the math. So imagine that like this is the case that you got your first 2 cards were clubs and then your next 3 weren't. Does that make sense? Wait, sorry. Wait, there were 3 that you want successes on. So that'd be 1/4, 1/4, 1/4, 3/4, 3/4, right? Do you guys understand how there are 3 successes here and 2 failures? And that's this, 3 successes, 2 failures. And then this part right here is saying, what if it wasn't the first 2 that, or the first 3 that were the successes? What if it was instead this one, and this one? You see what I mean? So this shows all the combinations of you picking different spots, essentially. How many different ways you can choose 3 out of 5. So that's where that comes from. All right, so try it in your calculator now. Make sure you put everything in parentheses. It needs to be in parentheses. Did you guys also get 0.0879? Okay. All right. So now we've learned how to use the formula. Everybody feel comfortable using the formula? Awesome. There's actually a way to do this on your calculator that is just a direct way, like it's right under the probability thing. So we're going to now look at that. That's called binomial. Binome, I think. Let me look. Is that? No. There it is. Yeah, binome. And then there's a PDF and a CDF function. And it is NPX. All right, so to get here, you are going to hit the second button and then the one that says distribution, where it says VARS on it. So everybody right now on your calculator hit second, and then it's like right next to the clear button. You see it, VARS? It says distribution up on the top. It's right next to clear. It's right here. This one. Right next to clear, it says vars or distribution on top. Okay, so now you end up on this screen, yeah? And you're gonna scroll down until you see the one that says Binomial Pdf. That's the one you want. PDF, not CDF. We'll talk about CDF in a second. That pulls that up on your screen. And then you're gonna put them in order, N and then comma P, comma X. Okay, so we're gonna try right now, number 1. So what's our N for this? How many trials are we doing for this down here? 5, so 5, comma. And then it says P. So that's the probability of success. That's 1/4. So put in 0.25 or 1 divided by 4, comma. And then X is how many successes you want. And right now we're looking at the 1 column. So you're going to put in 1 there. Can somebody tell me, why doesn't your calculator ask for the probability of failure? Yeah, I can figure it out by knowing the probability of success already. So if you hit an enter there, I got 0.3955. So I guess here I'll just write Binomial Pdf. We put in 5.251 and we got 0.3955. All right, try it again for the next one. If you just hit second enter, it'll bring up exactly what you just did. So if you hit second enter right now, it'll just bring up exactly what you just did, and you can just change the 1 to a 2. And you get 0.2637. Does everybody understand? You could use a formula for all of these. You could use a calculator for all of these. I'm just trying to show you the different ways. All right, now what we're going to do is I want you to hit, is everybody on the same spot? Are we all good at home? Caitlin, Tanner, Michaela, you guys are all using your calculator, okay? Caitlin, are you all right? Hey, Caitlin, are you good? Do you have a calculator?
Yeah.
Okay. All right, so then everybody go back to exactly where we just were, but this time instead of picking Binomial Pdf, pick Binomial Cdf. Pdf is talking about a singular point. CDF is cumulative. So I'm going to write that over here. Binomial CDF is cumulative. Does cumulative have 2 M's in it?
No.
Okay. So for example, if I wanted to know like 2 or less, right? What I could do is I could figure out, I mean, it's pretty easy right now because I could just add up 0, 1, and 2, right? But let's suppose I didn't have a chart in front of me and I just wanted to know the probability of between 0 and 2. Then I would write this, the same thing again. I'd write, there's 5 trials. The probability of success is 0.25, and I want a cumulative up through 2. And then if I hit enter, I get 0.8965. 0.8965. And then if I went down here and I added up these first 3 things, 0.2373 plus 0.3955 plus 0.2637, you see, that would be the same thing. So the idea is essentially that it'll sum it up for you if you want it to. All right, the last thing is using the back of your book. So everybody take out the back of your book, turn to page, I have no idea.
little thing.
Yeah, isn't that cool?
Oh, I didn't even notice.
A8. This is on page A8 through A10. All right. This is probably the easiest of all of them, but it only works to a certain amount because there's only so many tables in your book. So here's how you read this table. Everybody at A8? All right. So I'm going to use a ruler. Anybody in here want a ruler too? Help line up numbers. You need one, Krista? Mitchell? You can just keep these. All right. So we're going to start with N on the side. We've got 5 trials. And then X is right next to it. So right now we're trying to figure out 4 in that chart. I'm putting down my ruler. And then you just have to, on the top is just what P is. So P in this case is 0.25. So the answer for 4 is 0.015 right here. And while we're there, the answer for 5 is 0.001. So 0.015, I think, and 0.001. And this is page A8. So let's just check really quick and see if all of this adds up to 100%, or at least close to. I got like 1.0004. Pretty close. A little over maybe, but pretty good. All right, and that's how you do a binomial distribution, or at least 3 ways to do a binomial distribution. Everybody feel comfortable with all the ways? Awesome. Okay. So yep. All right, so now what we're going to do is you are going to try the exact same thing again. Only this time, I'm just going to leave you be. And I'm going to do it at the same time. But you're going to check and see if you can do it. All right, it says that Leah, Allie, Kelsey, Maddie, and Sierra are hanging out together. They're talking about whether they will come to school on senior skip day or just stay home. They each decide they have a 60% chance of coming to school. So we have to figure out all of these. All right, so again, this is using the formula for number 0 and 3. These 2 are going to be for the table. And these 2 are going to be using your calculator. Okay, so I'm also going to be doing this problem up here. And you can just look up and check in when you are wondering if you got it right, okay?
Wait, Miss Sunshine, is that 0.6 and not 0.8?
Yep. Dang it. Well, guess who gets a prize? You do. You want a lion? Oh, sad. It's okay, lions. There's 2 lions. Nobody wants you. You want one of the new animals?
Oh, kinda.
Okay. All right, looks like we got another hippo, but this is a different hippo than the hippo you have. Just to clarify, here's what your hippo looks like, because that's what Caitlin's hippo looks like, and here's what the new hippo looks like.
New hippos like a different color.
Uh-huh, totally a different
Blue
color.
eyes.
Yeah, it's got blue eyes, it's all black. It's weird looking. And then we got a giraffe and a zebra and a camel and a rhino.
I kind of want a herd of hippos. I'll take it.
All right. You gotta have a collection.
Probably eats 3s. That has a big amount.
Aww.
Instead of 2s.
Oh, this is why I like you so much. Are you guys enjoying yourselves? Hilarious. All right.
Oh, can I go to the bathroom?
Sure. And just so you know, people online, I'm not going to let you go until you turn in your homework from yesterday. I just put a Dropbox on. So if you want to, if you're already done with this part, you want to take a second to take a picture. This last part's going to be very easy. How are we feeling? Oh, we still got some people working. I need to do these calculus assignment ones. So Mr. Justman lives right by me. And he was having some car trouble recently, and so he asked if I'd pick him up this morning, give him a ride to work. So I picked him up, and my son was in the back seat. And my daughter too, but she was quiet. But Zandy, like, so Mr. Justman and I are talking as I'm driving, and Zandy interrupts me like mid-sentence, and he's like, "Who are you?" And Mr. Justman's like, "My name's Joe." And he's like, "Oh, hey, Joe." And Mr. Justman's like, "Hey, Zandy." And they're like, "Yep." And then he said his name like 8 more times in the car. And then when we were in school, got to school, then Zandy settled down, had like a snack and stuff in my room before he got on the bus. And then he was like, "Where's Joe? Joe has a room? Where's Joe's room?" And so then we had to go see where Joe's room is. Yep. I really can't imagine a kid not liking Mr. Justman, so. How'd you guys do? Everybody get them all right?
Yeah.
Caitlin, Michaela, Tanner, you guys good? Okay. All right. So the last few are just some simple formulas actually, and they're super easy. You know how like variance and standard deviation has been like a pain in our butts for a long time, especially variance and standard deviation, making those big charts. A binomial mean and variance is like the easiest thing ever. So a mean is just n times p. A variance is n times p times q. You already checked your answers, right, Megan? Oops, oh, like I put a period behind it. So if variance is n times p times q, then what's standard deviation? How does standard deviation and variance, or how are they related? Yep, so be the square root of npq is standard deviation. And that's it. So actually finding the mean and the variance and the standard deviation of a binomial is super easy. In Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Oh, I never talked to you guys about when can you not use the table in your book?
When it's like a different percent.
When it's a different percent than what's on top, because on top it's all like by 5%, right? So it works for like 80% or 60% or 25%, but it wouldn't work for 56% because 56% isn't in the book. Also, it wouldn't be in the book for 56 for a problem if it was like, I think the n goes up to 20 in the book, and then after that it's not in there anymore. So, all right. So about 56% of the days are cloudy. Find the mean, the variance, and standard deviation. No problem. All right. So first we just got to talk about what n, p, and q are for this problem. It says the month of June. How many days are in June? 30. Probability of it being cloudy is 56%. Probability of it not being cloudy is 44%. And then you just do some math. And because we're talking about days, for the mean, I got like 16.8, but that would be 17 days. Is about how many you would expect to be cloudy. Okay, you guys remember that you only have to do 3/4 of every assignment. And I let you choose which fourth it is that you don't do, or you can do all of it, depends on your comfort level. Everybody look up on your homework. I definitely want you to do number 15, where you have to use the table the whole time. 17, I want you to use the formula the whole time. And 19, I want you to use the calculator the whole time. And then you can pick which ones you do out of the rest. But definitely do those 3, okay? Anybody have any questions for me?
Do you have any batteries in the calculator?
Yep. I'll give you some in just a second. Michaela and Tanner, I've got your assignments, so you guys can head out. Caitlin, you still need to take notes, right?
I'm working on it starting right now.
Okay, so why don't you just stay on the call, and then I'll just mute myself and you can just work, okay? Hey, Caitlin? The homework for tonight's stuff is actually page 210, not 310. Just so you know. Right, these aren't the same problem. This is expected value,
So you're just what are you trying to find the other one?
just the probability. So like, see, that is the other one.
Yeah.
Without that bottom row, there's no bottom row.
Yeah, but the final bottom row, you did do the top one.
True, but in the other problem, there's no reason to do the bottom row because we're not asking that question at all. The bottom row is just for expected value.
Oh, you,
Right, so just the top 2 rows are what you're trying to find for the warm-up. Megan needs batteries. This is my song about Megan needing batteries.
So from, are you doing the play alone or is Miss?
Mr. Wilmus and Ms. Mullen is helping.
Oh, I've never met her.
She's really nice and she's fun. Okay,